Hemantha Lakshmi from Andhra Pradesh. I am currently pursuing BTech third year from RVRNGC College of Engineering. Our project is speech emotion recognition using deep learning. The aim of the project is detection of emotions elicited by the speaker while talking. In particular, we are presenting three different classification models such as CNN, MLP and SPM based on acoustic features such as MFCC. The model has been trained to classify 8 different emotions as neutral, happy, sad, anger, fearful, disgust and surprised. For this evaluation, the dataset is built using 5255 samples from RAVDES and test datasets. The accuracy scores finally are about 86%, 83% and 82% for CNN, MLP and SVM respectively. My team members will be implementing the model and also will be explaining the implementation details. Thank you.
Hi everyone, my name is Aditya Kamukar from Father Rodrigues Institute of Technology. I will show you implementation of MMP classifier. So this is the model. MMP classifier for speech emotion recognition. Our dataset consists of revdays and tests having audio file, speech and song file. Our dataset is mounted on Google Drive. Now we are installing libraries. Librosa sound file, NumPy, SKM per audio. Librosa is for music and audio analysis. And now we are importing our libraries: Librosa, Soundfile, OS Globe, Pickle, NumPy is NP. From sklearn model selection, we are importing train test spread from sklearn neural network, MLP classifier from sklearn matrix, importing accuracy score. Now we are defining extract feature function to extract uh, MFCC chroma mel from sound file. This function has four parameters: file name, MFCC chroma mel, x comma sample rate. We are loading the file name, resample type Kaiser fast. If chroma is true, then we get short Fourier transform of x and store the result in empty numpy array. If MFCC is true, then we are finding out the mean and store the result in extract function. If same for chroma and mel, and then return the result. Now we are defining the dictionary to hold numbers and emotions available on revdays and test dataset. The 8 emotions are neutral, calm, happy, sad, angry, fearful, disgust, surprise. So we are observing all these 8 emotions. Now we are loading the data and extract the features from each sound file. This is the path of our dataset, and we are extracting features MFCC chroma mel. Then we are splitting the dataset to training and testing, keeping 75% for training and 25% for testing. Now we are observing the shape of training and testing dataset. 3939 is for training shape, and 1313 is for testing test shape. Number of features extracted are 180. Now we are using MAP classifier. It's a internal neural network for classification, and it's also called feed forward artificial neural network. So here we have kept alpha 0.01, batch size 256, epsilon 1e dash 08, hidden layers 300, learning rate adaptive, and max iteration 500. Then we are fit and train the model. So we are activation is ReLU here and learning rate adaptive. Now we are predicting predict the accuracy of our model. So why predict? In a model dot predict x test. To calculate accuracy of our model, we have imported from sklearn this function accuracy score, and we are rounding the accuracy to two decimal places, and we got 83.32% accuracy. This is a classification report where we got 83% accuracy, and this is a F1 score we call precision, and these are confusion matrix. Thank you.
Hello, this is Khadija Mohammed Hanifa of Vidya Academy of Science and Technology, Kerala. I will start with the first phase of our project, that is feature extraction. We have used the Librosa Python library to extract the audio feature from all the audio files by loading resample files and computing the MFCC feature with the Librosa library functions. Corresponding emotion class is also noted. Both Raptors and test datasets are loaded for the selected 8 emotion classes and added to a dataset containing the features and labels obtained using the extract feature function. Here we see the SVM algorithm for training the obtained dataset. We have kept the training and test sets in the standard 80:20 ratio. We have created a pipeline that scales the input using standard scaler before classifying using the SVM SVC classifier. Note that the accuracy increases by a large margin after scaling. The training and testing scores were found to be 86 and 82 respectively, suggesting that the model generalizes well. The classification report and confusion metrics for the model is shown here, indicating best performance on the neutral class and worst performance on the calm class. Clearly, there is room for improvement with more data.
So hello guys, I am Abhay Gupta, second year computer engineering student pursuing my BE degree from Vivekanand Educational Society, Institute of Technology, Mumbai. So now I am going to tell you about the CNN model which we have used. So for training the model we have used RevDes and the test dataset. From the RevDes dataset we have used 1440 speech files and 1012 song files from the RevDes dataset and 2800 files from the test dataset. So I'm now going to tell you about the CNN layer which we have used in this model. So first we have a convolution 1D layer. Then we have an activation function which is a ReLU activation function. Then we have a dropout layer. And then we have max pooling layer to avoid overfitting. Next, again we have a convolution layer, but this time we have increased the number of filters from 64 to 128. And similarly we have used a ReLU activation function, dropout function and a max pooling layer to avoid overfitting. Then we have a third convolution layer in which we have used 256 filters. Then we have an activation layer which is a ReLU activation layer. Then we have a dropout function. We have a flatten layer to convert the n-dimensional matrix we get from the above layers to a one-dimensional matrix to provide to a dense layer. And then finally the dense layer provides the input to the softmax activation function we have used. And then softmax activation function gives the different probabilities which we get by training our model. So in total we have used 209,672 trainable parameters in this model. So we have trained our model on 200 epochs. So after 200 epochs, we can see our accuracy. The test training data accuracy is 90.39% and the validation set accuracy is 85.47%. So as you can see, there is not much difference between the training set accuracy and the validation set accuracy. So there is no overfitting in our model. You can see that also from the loss graph here and the accuracy graph. This is the Django framework where we have deployed our deep learning model. So in this we can upload audio file, choose file. So we can go to the dataset which you want. If you want that, which is, and we upload the file. File successfully uploaded. Then we go to the makeup prediction tab, and then we select the audio file. If we select this, we can hear to the
dass
file.
wir sie am Mittwoch abgeben.
Then we can go back. Then we select the audio file, and then we click predict. So as you can see, the emotion of the speaker in a file is sad.